In this case, the system was inconsistent. You could think geometrically it's because I have three planes that don't cross ever. So those three planes never meet. If I change the system just slightly, so if I change this 9 right here to an 8, the system becomes consistent. It has a solution, but now it actually has infinitely many solutions. Let's go through Gaussian elimination, where we get down to echelon form and then back substitution for this problem. I can see I would like probably I could add one, I could take negative 1/2 times the first equation and add it to the second equation to get the x's to disappear. But I probably would like to switch equation 1 and equation 2 again. That's a legal operation. Writing these equations in a different order won't change the solutions to those equations, so that's perfectly fine to do. And we had done that before, actually, when working with this problem, when it was a 9 instead of an 8 in this corner. Okay, so we can see again what we need to do is to take negative 2 times equation 1 and add it to equation 2 to get a new equation 2 that doesn't have an x in it. And we'll take negative 3 times equation 1 and add it to equation 3 to get a new equation 3 that also doesn't have an x in it. When I do that, again, I'm not changing the first equation, so x plus y plus 2z still equal to 4. But now I'm taking negative 2 times the first equation, adding it to the second equation to get a new second equation. So 2x minus 2x is nothing. Negative 2 times y plus negative 3y is negative 5y. Negative 2 times 2z is negative 4z plus 5z is plus z. And negative 2 times 4 is negative 8 plus 4 makes negative 4. Now let's go ahead and change our third equation as well by taking negative 3 times the first and adding it to the third. So negative 3x plus 3x is nothing. Negative 3y and negative 2y makes negative 5y again. And negative 3 times 2z is negative 6z plus 7z gives us c. And negative 3 times 4 is negative 12. Negative 12 plus 8 is negative 4. Now you might notice that my second and third equations are the same. So what this tells us is basically whenever the first equation is true, then the second equation looks like this and the third equation looks the same. So assuming that the first equation is true, the second and the third equations carry the same amount of information. Carry the same exact information, not the same amount, but the same exact information. If we didn't notice that those were the same, and so that one of these solutions had dropped out, we could always just keep going. We have a negative 5y here. We want to eliminate that negative 5y there, so we should take negative 1 times equation 1 and add it to times equation 2, and add it to equation 3 to get a new equation 3. So I'll just recopy my first equation, and I'm not changing my second equation, so I'll recopy that as well. And now I'm going to take negative 1 times the second and add it to the third. So negative 5y would be plus 5y, add it to negative 5y, no more y's. Negative z plus z is going to be 0, and so on the left-hand side, the y's and the z's all disappeared. I'll just write a 0 there. And on the right-hand side, negative 1 times negative 4 is 4. 4 plus negative 4 is 0. This time I came up with an equation that is always true. And so this equation doesn't really carry any information, right? It doesn't matter what x, y, or z are. This equation will always be true. So what happened here is we now had the system sort of reduced to a system of 3 equations, or 2 equations, and 3 unknowns. That means that there's not enough information to specify everything, which means one of the variables is left free. Now, when we get it into echelon form like this, the variables that that correspond to the first part of one of these rows are called pivot variables. So x is a pivot variable because it leads out in the first equation, and y is a pivot variable because it is there at the far left in this second equation. But z is not at the far left of any of these 2 equations, so z is not a pivot variable. So it's traditional to choose, if there are any variables that aren't pivot variables, to let them be the ones that are free. So let's just assume that z can be whatever it wants. So z is free. Once we choose a value of z, though, then we could solve for y. So negative 5y would be negative 4 minus z. Or if I divide by negative 5, y is going to be negative 4 divided by negative 5 is 4/5, and negative z divided by negative 5 would be plus 1/5 z. So z can be whatever it wants, but once you've made a choice for z, then that completely determines what y will be. And once you know what y and z will be, you can substitute them into the first equation. So y, we decided, is, so we have x plus y, but y is 4/5 plus 1/5 z, and then we have plus 2z is equal to 4, and now we can just solve for x in terms of z. So let's see, 2z is 10/5 and 1/5 makes 11, 2/5 and 1/5 make 11/5 z, and then we'll move this 4/5 over. 4 is 20/5, take away 4/5 would be 16/5. Let's just move this z over. X is negative 11/5 z plus 16/5. So now we can see there are actually infinitely many solutions to this problem. You can choose one of the variables is free. So for example, you could say, well, let's let z be whatever it wants, but then y has to be 1/5 z plus 4/5, and x needs to be negative 11/5 z plus 16/5. So in this case, you can see the solution, there are infinitely many solutions. In that case, we say the system was dependent. So you can see the values of x and y depend on what z is, or another reason for why it's dependent is actually that this third plane actually was dependent on the first two. This third plane didn't carry any additional information. You can kind of see it in the way these are written. If you add the first two equations, you get the third one, right? So the third one doesn't carry any information that wasn't already in the first two. Okay, so the third equation depended on the other two, and that's what meant that we had a free variable, because we didn't have enough information because the third equation didn't carry anything new. And so we had to, in order to solve, the solution depended on that free variable.